What was going through your mind? How amazed were you to see your roadster up there with Starman just cruising along with the Blue Planet? And how long will we be getting live views, do you think, from the car?
Well, I think it looks so ridiculous and impossible. And you can tell it's real because it looks so fake, honestly. Like, we'd have way better CGI if it was fake. And you know, the colors all look kind of weird in space. There's no atmospheric occlusion. You know, like everything looks too crisp. But we didn't really test any of those materials for, you know, is it space hardened or whatever, you know. So it just has the same seats that like a normal car has. It's just literally a normal car in space, which I kind of like the absurdity of that. And if you look closely, on the dashboard, there's a tiny roadster with a tiny spaceman. So, because Hot Wheels made a Hot Wheels roadster, and a friend of mine suggested, hey, why don't you put that Hot Wheels roadster with a tiny spaceman on the, you know, in the car too? I'm like, that'd be cool. Sure. So we did that. I mean, it's kind of silly and fun, but I think that's, you know, silly, fun things are important. And normally for a new rocket, you know, they'd launch like a block of concrete or something like that. I mean, that's so boring. And I think that's just the imagery of it is something that's going to get people excited around the world. And it's still tripping me out. I mean, I'm tripping balls here.
Nick, next question in the room. How about Brendan Byrne from WMFE, the NPR affiliate in Orlando?
Yeah, congratulations, Elon. Great launch today. Where do you see the Falcon Heavy fitting into this launch industry? Is this something that is going to be for more national security? You see this for interplanetary missions? What's the future of Falcon Heavy?
Yeah, the great thing is, like, so Falcon Heavy opens up a new class of payload. So it can launch more than twice as much payload as any other rocket in the world. So it's kind of up to customers what they might want to launch. But it can launch things direct to Pluto and beyond. You know, no stop needed. You don't even need like a gravity assist or anything. And you could launch giant satellites. It can do anything you want. You could go back. You could send people back to the moon with a bunch of, you know, if you did a bunch of launches of Falcon Heavy and did an orbital refilling. The two or three Falcon Heavies, you know, would equal the payload of a Saturn V. But I wouldn't recommend doing that because I think the new architecture, BFR architecture, is the way to go. But I think it's going to open up a sense of possibility. I think it's going to encourage other companies and countries to say, hey, if SpaceX, which is a commercial company, can do this, and nobody paid for Falcon Heavy, it was paid for with internal funds, then they could do it too. So I think it's going to encourage other countries and companies to raise their sights and say, hey, we can do bigger and better, which is great. We want a new space race. Space races are exciting.
How about one more in the room? How about Daryl Neal from the Fox affiliate here in Orlando?
Mr. Musk, kind of talk us through your thought process as you were watching the launch. You said you were incredibly concerned about it. Just, you know, you just wanted to clear the pad because it kind of set expectations low. So talk me through as you were watching it.
Yeah, I think this is true of anyone who's involved in, you know, closely in the design of something. You know all the ways they can fail, and that's like the sort of mental checklist that's scrolling through your mind. Is all the things that can break. I mean, there's thousands of things that can go wrong, and everything has to go right once the rocket lifts off. There's no opportunity to do a recall or upload a software fix or anything like that. It's either passing grade is 100%, at least for the ascent phase. Yeah, I've seen rockets blow up so many different ways. So, you know, it's a big relief when it actually works.
One more question in the room, and then
I
we'll go
bet
to
the first,
phone.
when they
I'm
first,
sorry.
whoever's like, when they were like first launched like a 747 or DC-3 or something like that, I bet the chief engineer was like, I can't believe that thing's flying.
One more in the room, and then we'll go to the phone. How about Irene Klotz from Aviation Week? Irene? We need to have you on mic first for the folks on the phone to hear.
Thanks. I can hold it. Okay. Thanks, Irene Klotz with Aviation Week. Congratulations. Can you talk to us a little bit about what needs to happen to certify Falcon Heavy for the national security missions? How far along you are in that process, and how many flights you might need to do? And also, if you're able to say anything about how much your SpaceX's investment to get to the rocket to this point. Thanks.
I think we only need, I think there's I'm not, it just depends on which national security mission that we'd need to, how many flights depends on which mission. But we have a number of commercial customers for Falcon Heavy. So I think, I really don't think it's going to be in any way an impediment to acceptance of national security missions. Because we'll be doing several Falcon Heavy missions, flights per year. So let's say if there's a big national security satellite that's due for launch in 3 or 4 years, we probably have like a dozen or more launches done by then. So it won't really, I don't think there'll be a launch number that's an inhibitor on national security stuff. And then we've got the STP mission that's coming up, which is another test mission. That'll go on where everything's on Block 5, version 5 of the rocket. And then we'll be launching version 5 or Block 5 single stick in a couple months. So I think it's hopefully smooth sailing for qualification for national security missions. Our investment to date, probably a lot more than I'd like to admit. We try to cancel the Falcon Heavy program 3 times at SpaceX because it's like, man, this is way harder than we thought. Because the initial idea was just like, you stick on two first stages of side boosters. How hard can it be? It's like it's way hard. We had to redesign the center core completely. We had to redesign the grid fins because it's a long story. But if you've got a nose cone on the end of at the end of the booster instead of a cylinder, you lose control authority. Because if you've got a cylinder, you can kind of bounce the air off of the rocket, and you get like 50% or more increased control authority if you've got a cylindrical section instead of an ogive section at the end of the booster. So we had to redesign the grid fins, redesign the control system, massively redesign the thrust structure at the base to take way more load. That center booster's got to deal with over 1 million pounds of load coming in combined from the side boosters. So it ends up being heavier. So the center core is basically a complete redesign. And even the side boosters, there's a pretty large number of parts that change. And then the launch site itself needs to change a lot. I'm guessing our total investment is over $500 million. Probably more. Yeah.
I'd like to take some questions from the phone. I think the first one up is Dan Vergano from BuzzFeed News. Is that right?
That's right. Dan Vergano, BuzzFeed News. Could you talk a little bit about the decision to have the 2 side cores come down at the same time? Is that just the way it falls out from the physics, or was that an actual decision you made?
We did offset them slightly, but really they pretty much just come down. That there's no. We wanted them to offset slightly just so that the radars didn't interfere. And we actually wanted no communication between the 2 stages. They're both going to a point in absolute space. And we're just worried that the radar reflection of one would be seen by the radar receiver of the other. But no, that's just kind of how it happened. It's actually meant to happen just like that.